What if the story we tell about ourselves is only the last page of an immense book whose previous chapters were torn out by time itself? What if the lights of our cities, shimmering in the darkness of space, are not the first dawn of consciousness on this planet, but a recurring twilight, a light that once shone and faded away in unimaginably distant eras? The question that will guide us through this nocturnal journey is not simply whether intelligent life existed before us, but whether a complex civilization, with art, dreams, and technology, rose and fell into the abyss of geological time, long before the first dinosaur ever walked the earth. How could something so vast disappear so completely, without leaving behind even a shadow? This is a journey into the depths of time, an invitation to imagination guided by science, to explore the blank spaces on the great map of existence. If you enjoy following those hidden clues in the fabric of reality and asking what mysteries they might reveal, consider subscribing to the channel so you won't miss the next explorations. Together, we will continue listening to the echoes of worlds that may once have existed, learning to decipher a story written not in stone, but in the silence of the planet itself, a silence that may hold more secrets than all our libraries combined. With every new question, we step closer to the heart of an enigma that defines us. Our perception of time is fragile, shaped by the brevity of our lives. We measure history in centuries, perhaps millennia, but the planet thinks in eons. Earth is 4.5 billion years old, an ocean of time so deep that the entirety of our civilization is no more than a thin film of foam atop its waves. In this vast ocean, there has been room for countless tides of life to rise and fall. To imagine that ours is the only wave to reach the complexity of self-awareness might be an act of profound loneliness, or perhaps profound arrogance. What if other waves, equally magnificent, have already reached the shore and receded, leaving behind only wet sand as fleeting proof of their passage? The planet is a master of recycling, an architect of absence. The Earth's crust is not a permanent archive, but a canvas in constant transformation. Tectonic plates slide over one another in a slow, relentless dance, dragging entire continents into the mantle, where they are melted and reborn. Mountains, which to us seem symbols of eternity, are worn down by erosion until they become grains of sand. Ice ages advance like planetary sandpaper, scraping the surface and redrawing entire landscapes. The Earth not only creates, it erases. It devours its own children, digesting their cities, their bones, and their memories in an endless cycle of forgetting and renewal. Faced with this process, searching for the ruins of a prehistoric civilization would be like searching for a sandcastle after a storm. If evidence exists at all, it would not be in monumental structures, but in whispers, ghostly echoes in geological data, a chemical anomaly in a layer of rock, an unexplained disruption in the fossil record, an isotopic signature that shouldn't be there. Perhaps the legacy of a lost world is not a city of stone, but a subtle scar in the planet's own biology, a memory encoded in the DNA of life forms that came after. Perhaps the evidence is all around us, disguised as nature. And so the question shifts. We are no longer asking, where are the ruins? But instead, have we forgotten how to read the silent language of our own world? This language is not made of words, but of layers of time, of mass extinctions and sudden bursts of life. It is a history told by absence, by what is missing in the record. Before we plunge into hypotheses and anomalies, we must first accept the fragility of our own history and the immense capacity of time to erase even the grandest of creations. We are about to leaf through a book where most pages are blank, and it is in this emptiness that true exploration begins. To begin our search for a lost world, we must first understand the map that science offers us. It is a map of vast ages, where our very existence is but a tiny scribble in the margins. Earth, with its 4.5 billion years, witnessed the slow, tentative birth of life almost 4 billion years ago. For eons, existence was a monologue of microbes, a planet breathing without lungs, dreaming without mind. Complex life, with tissues and organs, only, exploded onto the scene some 540 million years ago, in an event so sudden and dramatic we call it the Cambrian explosion. It was the true dawn of the animal kingdom, the beginning of a new era. After that, life blossomed into strange and wondrous forms. The dinosaurs, the iconic rulers of the past, reigned from about 245 to 66 million years ago. Their era was long, powerful, and ended in fire. By comparison, our species, Homo sapiens, has existed for only 300,000 years, and our civilization, with its cities, writing, and recorded history, is a fleeting breath of just 6,000 years. This timescale is nearly impossible to internalize, a temporal vertigo that places us in our true context. We are newcomers, dwellers of an instant. The most poetic way to visualize this immensity is to compress Earth's history into a single year. If the planet formed on the 2nd of January the 1st, the simplest life would not appear until March. The dinosaurs would arrive just in time for Christmas, dominating the last 2 weeks of December. And all of human recorded history, it would unfold in the final 10 seconds before midnight on December 31st. Our industrial age, with its machines and pollution, would last less than a fraction of a second. In this scale, entire weeks and months, vast stretches of time, remain almost completely unknown to us. This is only the beginning of your text, translated into English. Would you like me to continue and translate the full text in one go? It will be very long. Or would you prefer that I break it into several large sections so it's easier to manage and review? You said, okay. ChatGPT said, here's your complete, uncut translation to English. I kept meaning and tone intact, only smoothing phrasing where needed for natural flow to an English-speaking audience. What if the story we tell about ourselves is only the last page of an immense book, whose previous chapters were torn out by time itself? What if the lights of our cities, shimmering in the darkness of space, are not the first dawn of consciousness on this planet, but a recurring twilight, a light that once shone and faded away in unimaginably distant eras? The question that will guide us through this nocturnal journey is not simply whether intelligent life existed before us, but whether a complex civilization, with art, dreams, and technology, rose and fell into the abyss of geological time, long before the first dinosaur ever walked the earth. How could something so vast disappear so completely without leaving behind even a shadow? This is a journey into the depths of time, an invitation to imagination guided by science, to explore the blank spaces on the great map of existence. If you enjoy following those hidden clues in the fabric of reality and asking what mysteries they might reveal, consider subscribing to the channel so you won't miss the next explorations. Together, we will keep listening to the echoes of worlds that may once have existed, learning to decipher a story written not in stone, but in the planet's own silence, a silence that may hold more secrets than all our libraries combined. With every new question, we step closer to the heart of an enigma that defines us. Our perception of time is fragile, shaped by the brevity of our lives. We measure history in centuries, perhaps millennia, but the planet thinks in eons. Earth is 4.5 billion years old, an ocean of time so deep that the entirety of our civilization would be just a thin layer of foam on the surface of its waves. In this vast ocean, there has been time for countless tides of life to rise and fall. To imagine that ours is the only wave to reach the complexity of self-awareness might be an act of profound loneliness, or perhaps of profound arrogance. What if other waves, equally magnificent, have already reached the shore and receded, leaving only wet sand as fleeting proof of their passage? The planet is a master of recycling, an architect of absence. The Earth's crust is not a permanent archive, but a canvas in constant transformation. Tectonic plates slide over one another in a slow, relentless dance, dragging entire continents into the mantle where they are melted and reborn. Mountains, which seem to us like symbols of eternity, are worn down by erosion until they become grains of sand. Ice ages advance like planetary sandpaper, scraping the surface and redrawing entire landscapes. Earth not only creates, it erases. It swallows its own. Children, digesting their cities, their bones and their memories in an endless cycle of forgetting and renewal. Faced with this process, searching for the ruins of a prehistoric civilization would be like searching for a sandcastle after a storm. If evidence exists at all, it would not lie in monumental structures, but in whispers, ghostly echoes in geological data, a chemical anomaly in a rock layer, an unexplained disturbance in the fossil record, an isotopic signature that shouldn't be there. Perhaps the legacy of a lost world is not a city of stone, but a subtle scar in the planet's own biology, a memory encoded in the DNA of life forms that came after. Perhaps the evidence is all around us, disguised as nature. So the question shifts. We are no longer asking, where are the ruins, but rather, have we forgotten how to read the silent language of our own world? This language is not made of words, but of layers of time, of mass extinctions and sudden bursts of life. It is a history told by absence, by what is missing from the record. Before we plunge into hypotheses and anomalies, we must first accept the fragility of our own history and the immense capacity of time to erase even the grandest creations. We are about to leaf through a book in which most pages are blank, and it is in this emptiness that true exploration begins. To begin our search for a lost world, we must first understand the map that science offers us. It is a map of vast ages where our existence is a tiny scribble in the margin. Earth, with its 4.5 billion years, witnessed the slow, tentative birth of life almost 4 billion years ago. For eons, existence was a monologue of microbes, a planet breathing without lungs, dreaming without a mind. Complex life, with multiple tissues and organs, only exploded onto the scene about 540 million years ago, in an event so sudden and dramatic that we call it the Cambrian explosion. It was the true dawn of the animal kingdom, the beginning of a new era. After that, life flourished into strange and wondrous forms. Dinosaurs, the iconic rulers of the past, reigned from roughly 245 to 66 million years ago. Their era was long, powerful, and ended in fire. By comparison, our species, Homo sapiens, has existed for a mere 300,000 years, and our civilization, with its cities, writing, and recorded history, is a fleeting breath of only 6,000 years. This timescale is nearly impossible to internalize, a temporal vertigo that puts us in our place. We are newcomers, inhabitants of an instant. The most poetic way to visualize this immensity is to compress Earth's history into a single year. If the planet formed in the first second of January 1st, the simplest life would not appear until March. Dinosaurs would arrive just in time for Christmas, dominating the last 2 weeks of December. And all of human recorded history, it would unfold in the final 10 seconds before midnight on December 31st. Our industrial age, with its machines and pollution, would last less than a fraction of a second. On this scale, there are entire weeks and months, vast stretches of time, about which we know very little. The official narrative tells us the path toward intelligence was singular and linear. Before the dinosaurs, during the vast Paleozoic era, the world was an alien landscape. Continents were grouped in strange configurations, the seas were shallow and teeming with trilobites in their segmented armor, and on land the earliest forests bore no flowers, only giant ferns and primitive trees. The atmosphere was denser, richer in oxygen, allowing insects like dragonflies to reach the size of birds. It was a world of silence, without birdsong or the hum of bees, a world that seemed empty of mind. In this ancient setting, conventional science offers no room nor the slightest evidence for an industrial civilization. There are no fossils of gears in the Carboniferous, no city ruins in Permian strata, and for that reason, the idea is relegated to the realm of fiction. Science is built on what can be observed and measured. Its power lies in tangible evidence. What it cannot do, however, is tell us with certainty what happened in the vast chapters from which no evidence survived. As we are reminded, absence of evidence is not always evidence of absence. Here, we encounter the great fragility of our knowledge, the geological record. Imagine Earth's history as a colossal library containing billions of books, one for each year. Now imagine that a fire followed by a flood and centuries of neglect destroyed 99.9% of the collection. What remains are fragments, a scorched page here, a book cover there, a few legible sentences amid volumes of ash. From these fragile and random remnants, we try to reconstruct the entire saga of life. The geological record is not a complete chronicle. It is a collection of survivors. Fossilization itself is a miracle of chance. For an organism to become a fossil, it must die in just the right place at just the right time, be quickly buried by sediment before it decomposes, and then remain undisturbed through millions of years of pressure, heat, and geological motion. The overwhelming majority of living things that have ever existed left no trace at all. They were eaten, they rotted, they dissolved. Their existence was real but fleeting, and the planet kept no receipt of their passage. How many entire biological worlds may have lived and vanished in these intervals of forgetting? Consider our own global civilization for a moment as an exercise in humility. Our cities of concrete and steel, our vast road systems, our mountains of plastic. If humanity disappeared today, within 100,000 years, nature would have reclaimed almost everything. Our cities would be green hills, our roads mere scars in the soil. Concrete would disintegrate, steel would rust into powder. Only a few synthetic materials and radioactive isotopes might survive as a whisper of our presence. And even these would be hard to find and harder to interpret correctly. Now extend that horizon. In 50 million years, the odds that a future geologist would find a clear, unambiguous proof of our civilization are incredibly small. Tectonic plates would have recycled much of the surface. Erosion would have leveled what remained. Our legacy would be a sedimentary layer with some odd spikes of nitrogen, plastic, and heavy metals. A geological anomaly perhaps attributed to unusual volcanism or an asteroid impact. A ghostly signature that could be misread or simply ignored. If it is so hard for us to imagine our own geological survival, how could we expect to find remnants of a civilization that might have existed 300 or 400 million years ago? It would be like searching for a single specific grain of sand across every beach and desert on Earth. The task is so monumental that it borders on impossible. Thus, the lack of a fossilized city or an integrated circuit in Devonian. Rocks does not close the question, it opens it. It forces us to look for much subtler clues, for shadows cast across abysses of time. The question then is not why we haven't found evidence, but what kind of evidence could survive such deep, relentless forgetting? What does Earth keep, if not the bones of a civilization, perhaps its chemical soul? To answer that, we must delve into anomalies, into those moments in Earth's history when something doesn't quite fit, moments when the planet seems to have suffered a trauma whose causes remain wrapped in mystery. It's in those moments that we may find the clearest echoes of a world before our own. To hunt geological ghosts, we need to know what one might look like. Our own civilization provides the perfect model. We are living in an era scientists propose to call the Anthropocene. the age of humans. It's a new chapter in Earth's history, defined not by a natural event, but by the indelible mark of our activity. Right now, we are laying down the rock layer that a future geologist could use to identify us. It will be thin, but extraordinarily peculiar, unlike anything that came before. And what will define it? The signatures of our technology. Think of plastic. We created materials that did not exist in nature, polymers that may take hundreds of thousands, perhaps millions, of years to fully degrade. Microplastics are infiltrating every ecosystem, from mountain peaks to ocean trenches. They will become part of the sedimentary record, transforming into plastiglomerates or molecular fossils. A distant future geologist might find these traces and wonder what natural process forged such strange, persistent carbon chains. It would be a silent yet unmistakable proof of a global industry. Beyond plastic, there is concrete. Never before in Earth's history has a single animal produced so much of an artificial rock. Our cities are, in essence, coral reefs made of cement, steel, and glass. Even after eroding, they will leave a distinct chemical signature, and our agriculture, the massive use of nitrogen fertilizers, has altered the global nitrogen cycle in unprecedented ways. That drastic shift will be recorded in nitrogen isotopes in sediments and even in ice cores, a clear sign of intentional planetary scale management. And of course there is carbon. Burning fossil fuels releases into the atmosphere carbon that has been locked underground for hundreds of millions of years. That carbon carries a specific isotopic signature, lighter, because it comes from ancient organic matter like plants and plankton. This shift in the balance of carbon isotopes in the atmosphere and oceans is perhaps our strongest, most enduring signature. It is a global shout that says, we were here and we were hungry for energy. But were we the first to shout? This question inspired a fascinating scientific thought experiment formalized by astrophysicists like Adam Frank and Gavin Schmidt. The Silurian hypothesis, named after an ancient reptilian civilization in Doctor Who. The question they posed was simple and profound. If an industrial civilization had existed millions of years ago, what traces would it leave behind? Their conclusion: don't look for cities, look for patterns, chemical and isotopic patterns identical to those we are creating today. The first place to look then would be past warming events. Earth's history is full of climatic shifts. One of the best known is the Paleocene-Eocene thermal maximum about 56 million years ago. Global temperatures spiked, oceans acidified, and there was a mass extinction. The commonly accepted cause is a massive release of methane or carbon due to volcanic activity. Yet the event bears a strange resemblance in its carbon signature to what we are doing now. Could that be mere coincidence? Burning coal, oil, and gas releases not only carbon, but a suite of other elements. Heavy metals like mercury, lead, and cadmium get lofted into the atmosphere and end up deposited in sediments. Our geological layer will be rich in these metals. Do other layers in the record show unexplained spikes of heavy metal contamination? We often attribute such anomalies to asteroid impacts or natural mineral seams, but what if some are the rusted remains of a forgotten industry? And what about fossil fuels themselves? The coal, oil, and gas that power our society are compressed remnants of ancient forests and seas. Earth's solar battery, charged over millions of years. If a previous civilization also discovered this energy source, it would have exploited and depleted the most accessible deposits of its era. Could there be gaps in the fossil fuel record, regions or periods where, strangely, there is less coal or oil than geological models predict? That would be a subtle absence that tells a story. Consider Earth's very structure. Our demand for resources drives us to move mountains, dig deep mines, and reshape the landscape on an unprecedented scale. These activities, megatons of earth moved, far exceed the sediment moved by all the world's rivers. Though erosion eventually softens these scars, they could leave anomalous sedimentary structures, pockets of displaced rock that tell a tale of deliberate extraction. Are we willing to reinterpret certain geological formations as possible ancient mines? Beyond chemistry, there is physics. If an ancient civilization mastered nuclear energy, the consequences would be even more enduring. A nuclear war or a reactor disaster would leave behind radioactive isotopes that do not occur in nature, like plutonium-244. With a half-life of about 80 million years, it could be detectable over geologically significant timescales. To date, no unequivocal traces of pre-human plutonium have been found, but time is vast, and our search has only begun. Nature, however, has nuclear surprises of its own. At Oklo in Gabon, there is a set of natural fission reactors that operated about 2 billion years ago. Underground uranium deposits, under specific water and geological conditions, initiated a self-sustaining chain reaction. This proves the planet can create processes that look artificial. Such ambiguity lies at the heart of the challenge. How can we distinguish the hand of a civilization from the equally powerful, creative hand of nature itself? The soil beneath our feet also tells a story. Large-scale agriculture with its deforestation and ploughing causes massive erosion. That erosion sends huge amounts of soil to the oceans, creating distinct sediment layers. A sudden spike in sedimentation rates during a given geological period could indicate the birth of agriculture on a planetary scale. We do see such spikes in the record, but they are always attributed to climatic or tectonic changes. But what if the cause wasn't the climate-changing life, but life changing the climate? Life itself could be an artifact. What if an ancient civilization did not focus on megastructures, but on biotechnology? The introduction or modification of species might leave a lasting legacy. Consider the Great Oxygenation Event more than 2 billion years ago, when cyanobacteria flooded the atmosphere with oxygen, a gas that was toxic to most life at the time. It was the first great global pollution event, and it was caused by life. Could an apparently natural event, an explosion of diversity, or a sudden plague, have been the result of forgotten biological engineering? This question urges us to look at Earth's great catastrophes with new eyes, the mass extinctions. There have been at least 5 major events that nearly reset life's clock. The most severe was the Permian-Triassic extinction about 252 million years ago. The Great Dying. It was almost inconceivably brutal. More than 90% of marine species and 70% of terrestrial species went extinct. Life on this planet came perilously close to being erased. The proposed causes for the Great Dying are all natural and catastrophic. Chief among them, massive volcanic eruptions in Siberia that covered an area the size of Europe with lava and released titanic amounts of carbon dioxide. That would have caused runaway warming, ocean acidification, and anoxia, oxygen loss in the seas. The scenario is plausible and well supported, but a quiet question remains. Does it explain everything, the full extent of the devastation? What most intrigues scientists is the speed and ferocity of the Permian extinction. The biosphere seems to have collapsed systemically and rapidly, a pattern eerily similar to what models predict for our own future if we continue on our current path. Could the Permian catastrophe have been more than volcanism alone? Could it have been a planetary system already stressed by another force, an industrial force, then pushed over the edge by a natural disaster? Imagine a Paleozoic civilization at its zenith. They too burn the fossil fuels of their time. Their oceans are already turning acidic, their climate unstable. They live on the knife's edge, as we do. Then nature strikes. The Siberian eruptions begin. The combination of pre-existing industrial stress and natural disaster would be a perfect storm, a 1-2 blow from which the biosphere could not recover. The civilization would not have caused the extinction, but would have set the conditions for it to become nearly total. In such a scenario, the geological signature would be tangled and overlapping. The signals of industry, carbon spikes, heavy metals would be masked and overshadowed by the much larger signals of volcanic activity. It would be impossible for a future observer to separate the two events. The industrial crime would be hidden inside a far greater crime of nature, a perfect murder, with the weapons swallowed by a volcano. It's speculative, yes, but it reminds us how complex geological narratives can be. Moreover, the recovery of life after the Great Dying was strangely slow. It took millions of years for ecosystems to rebound and diversity to return. Some scientists theorize that life's very mechanisms had been damaged, that the planet was sick for a long time. What could cause such persistent harm? Perhaps the release of long-lived synthetic pollutants, or the destruction of key elements of the biosphere that took eons to evolve. Perhaps Earth was not only recovering from a natural disaster, but from a poison. The challenge, therefore, lies in ambiguity. Every anomaly we find has a plausible natural explanation. A carbon spike can be a volcano. A metal deposit can be a mineral vein. A mass extinction can be an asteroid. Nature is perfectly capable of planet-scale catastrophes. We don't need a lost civilization to explain them, and yet the question persists: what if the natural explanation is only the cover story? Science advances by crafting the simplest explanations that fit the data. Occam's razor. An ancient civilization is an extraordinarily complex hypothesis, but as our own planetary impact becomes clearer, the idea that something similar might have happened before starts to seem perhaps a little less extraordinary. We are writing a field guide to how a species can alter its planet. Maybe it's time to use it to reread the oldest chapters. In the end, this layer of scientific inquiry does not give us answers, but tools and a new pair of eyes. It teaches us to search for signatures instead of structures, for echoes instead of voices. Earth's history may not be a straight line, but a series of palimpsests, where each new era writes over the previous one, but never fully erases it. The stains and shadows of the older text can still be seen if we know how to angle the light, and it is in those shadows that our search must continue. Science offers a coherent narrative of the past, but that narrative is like an old map with vast regions labeled terra incognita. It's in these unknown territories that we find anomalies, out-of-place artifacts that don't fit the story we tell ourselves. In human archaeology, we call such objects parts. The Antikythera mechanism, an astonishingly complex analog computer found in an ancient Greek shipwreck, is one example. For decades, it challenged our understanding of ancient technology. It didn't prove aliens. It proved our knowledge of our own history was incomplete. Now let's apply that logic on a geological timescale. We're not looking for gears, but for out-of-place events. Think of Earth's history as the restoration of an old, damaged painting. Most of the canvas is blank or irreparably stained, but in places the original image shines through, and sometimes what we see is disconcerting. These are moments in the planet's story that seem too fast, too violent, or too strange. They are the whispers that break the long silence, the notes that don't belong to the melody we know. The greatest of these anomalies is perhaps the Cambrian explosion. For more than 3 billion years, life on Earth was a club exclusive to simple single-celled organisms. Then, about 540 million years ago, in a geological blink, maybe 10 to 20 million years, the scene changed drastically. Suddenly, the oceans filled with a dizzying variety of complex animals. The first predators appeared, the first shells, the first eyes. Nearly all the major animal phyla that exist today appeared in that short interval. It was as if life had waited backstage for a cue to rush onto the stage. Imagine the history of life as a long, silent film in black and white. For hours, nothing happens but the slow motion of simple forms. Then, without warning, the screen bursts into vibrant color, the soundtrack swells, and the full cast of complex characters appears at once, already in the middle of an elaborate drama. Science offers natural explanations, a rise in oxygen levels, new genetic strategies, an evolutionary arms race between predators and prey. These are solid theories, but the poetry of the question remains: was it an explosion or an introduction? Leaving biology aside, the planet's very minerals sometimes display patterns that seem to defy randomness. Consider the hexagonal basalt columns at the Giant's Causeway in Ireland, structures so geometrically perfect they look carved by an intelligent hand. We now know they are the result of slow cooling and contraction of lava. Nature, it seems, is a gifted geometer, creating order from chaos, patterns that appear imbued with intent. On this thin line between natural and artificial, our imagination can roam. How many other geological formations have we dismissed as mere curiosities? Imagine finding a perfect cube of pyrite. Our logical mind knows it's a natural crystal structure, yet for a brief second, our intuition whispers, who carved it? Now scale that sensation up to an entire mountain, or a cave system with uncanny symmetry, or mineral deposits arranged in ways that strain probability. None of this proves anything, but it's an exercise in perspective, forcing us to question what is purely natural and what could be the eroded echo of a design. We could even think of thinking itself as an anomaly. Consciousness, the ability of a handful of organic matter to look at the stars and question its own place in the universe. It's the most complex, mysterious phenomenon we know. If it happened once along our primate lineage, why assume it was unique? Consciousness is like a fire. Given the right conditions, oxygen, fuel, and a spark, it arises. Perhaps Earth's biosphere, across its billions of years, assembled the right conditions many times. Perhaps the fire of consciousness has ignited and gone out again and again in forests we can no longer name. And what about gaps in the fossil record? They're famous, long stretches in which certain animal lineages seem to disappear and then reappear millions of years later, almost unchanged. These are called Lazarus taxa. The scientific explanation is that they survived in small refugees that did not fossilize, a perfectly reasonable answer. But, metaphorically, what are those refugees? Are they geographic or temporal? Isolated ecosystems, or perhaps deliberate reserves created to survive a catastrophe their makers knew was coming? Think of Earth as an old hard drive. Over time, it becomes corrupted and fragmented. Most files are lost forever, but some fragments persist in damaged sectors, a snippet of code, a pixelated image, a distorted sound. The Cambrian explosion, the great dying isotopic spikes, these are data fragments from an operating system we no longer recognize. Our science tries to rebuild the original file from these fragments, assuming they all belong to the same program. But what if they don't? Mysteries like these are only fragments of a much larger story. If you like following these hidden clues and imagining what they might mean, consider subscribing to the channel so you won't miss the next explorations. Every unanswered question is a piece of a puzzle we're assembling together. A puzzle that may reveal a past far stranger and more wonderful than we dare imagine. The journey into the unknown continues, and each new discovery takes us deeper into the heart of the enigma. To grasp the depth of forgetting, let's use a metaphor closer to home. Imagine spending an entire day building an elaborate sandcastle at the beach. Towers, walls, bridges. You photograph it, admire your creation, then you go home. The tide rises and falls. A storm hits overnight. Next day you return to the shore. There is no castle, not even a hump of sand to suggest something was ever there. Everything is once again a smooth, uniform beach. Now imagine the tide is not water but time, and each wave is not a wave but 1,000,000 years. One wave is an ice age scraping a continent. Another is a series of volcanic eruptions burying everything beneath kilometers of ash. Another is the slow dive of a tectonic plate, dragging your castle into Earth's mantle to be melted. After hundreds of such tides, what would remain of your castle? Absolutely nothing. Not a single displaced grain identifiable beyond doubt. That is the scale of the challenge we face. We're looking for a sandcastle on a beach swept by 1,000,000,000 tides. This is why the absence of fossilized cities means little. The true wonder, the true anomaly, would be if we found anything at all. The survival of any trace would be such a statistical miracle that it would demand an extraordinary explanation. So our search is not for miracles, but for the shadows of miracles, for grains of sand that under a microscope are the wrong shape. We might even think of water itself as a metaphor. Water is the great solvent, chemically and historically. It gives life, but it also erases it. It nourishes ecosystems, but it also erodes mountains and dissolves evidence. What if the civilization we seek was aquatic? Its buildings might have been biological structures, grown like coral reefs. Its artifacts might have been made of materials that dissolve in water over time. Such a civilization, living and dying in the ocean depths, would be nearly invisible in the geological record. Its cities would lie on the seafloor, the perfect place to be swallowed by subduction zones. Its waste would be dispersed by currents, diluted to the point of being undetectable. Its legacy would be a slight change in ocean chemistry for a few million years, an anomaly we would later attribute to natural processes. An aquatic civilization could rise to greatness and vanish while leaving almost no fossil to tell its story. They would be the true ghosts of the abyss. Another useful metaphor is ice. Imagine a civilization that evolved during a prolonged ice age, building its cities on or beneath vast ice sheets. Ice would be its construction material, its environment, its fortress. But ice ages are fleeting on geological scales. When the climate warmed, as it inevitably does, their entire world would melt. Their cities, their technology, their bodies, all would become water and flow into the sea, leaving behind only bare rock and newborn lakes. This idea reminds us that what we consider normal and stable is just one phase in Earth's long climatic cycle. A civilization could be perfectly adapted to a world that no longer exists. They might have been masters of a frozen planet, or of a world of shallow, warm seas, or of a supercontinent of vast deserts. When the planet changed, they could not adapt and disappeared. Their existence would be bound to a single page of Earth's book, a page turned long ago. We can also think of history as an echo. A sound travels, reflects off distant surfaces and returns, fainter, distorted. What reaches us from the deep past is not the original sound, but an echo of an echo. The Cambrian explosion may be the echo of a biological event. The Permian extinction, the echo of an industrial catastrophe. We listen to these faint echoes and try to guess the original sound, but the distortion is so great we can never be certain. This uncertainty is crucial. It keeps us humble. Anomalies don't give answers, but they grant permission to ask. They open a crack in the door of scientific orthodoxy, letting in a little speculative light. They remind us that history, human or geological, is always interpretation, a story we tell ourselves based on incomplete evidence. And sometimes the most interesting stories are not in the fragments we find, but in the lines we imagine to connect the blanks. Metaphors help us feel the immensity of the problem. The sandcastle, the corrupted hard drive, the the distorted echo. All point to the same truth. The deep past is a foreign country and its languages are dead. We cannot expect to read its newspapers or visit its cities. All we can do is look at the landscape it left behind and wonder, are the strange shapes in mountains and valleys only the work of wind and water, or the softened contours of a face we have forgotten? Finally, imagine Earth as a sleeping mind. The laws of physics and chemistry are its deep, steady breathing. But occasionally, this mind dreams. Dreams are the anomalies, bursts of creativity, nightmares of destruction, moments when the logic of the waking world is suspended. Life, intelligence, civilization, perhaps they are Earth's dreams. Dreams it dreams, forgets upon waking, and perhaps dreams again on another long night of eons. We, with our science and logic, are the waking mind, trying to analyze the fragments of a dream we don't understand. We try to fit them into our reality, calling them volcanoes or convergent evolution. But perhaps they don't belong entirely to the waking world. Perhaps they are an invitation to stop analyzing for a moment and simply return to dreaming with the planet, to imagine not only what was, but everything that could have been. With our minds open to the depth of time and the fragility of evidence, we can allow ourselves to speculate. We leave the firm ground of observation and step into the realm of plausible hypotheses, of worlds that might have been. If a civilization did exist, what was it like? The first and simplest hypothesis is that they were like us, a familiar echo. An Earth-born industrial civilization under the same sun, made of the same carbon. Imagine a world in the Carboniferous period, 300 million years ago. Forests of giant ferns stretch as far as the eye can see, and the air is so rich in oxygen that fire behaves differently and life can reach titanic proportions. In this setting, a species evolves, develops tools, masters fire, and eventually discovers the energy stored beneath its feet in the remains of even older forests. They build cities, perhaps not of concrete, but of materials unknown to us. Skies above their metropolises are crossed not by birds but by insects the size of eagles. Their story would be a distorted mirror of ours. They too would have an industrial revolution, releasing ancient carbon into the atmosphere. They too would face the consequences, a changing climate, acidifying oceans. Perhaps they saw the warning signs as we do. Perhaps their scientists published studies, their leaders made promises, and perhaps, like us, they acted too little, too late. Their fall would not be a single spectacular event, but a slow decline. A civilization drowning in its own success. Their end could have been the Great Dying. Perhaps the Permian catastrophe was not merely exacerbated by them, but entirely caused by them. A planet-wide nuclear war, whose detonations triggered volcanism and released trapped methane. Or, more subtly, a technology that spiraled out of control. Perhaps nanotechnology that consumed the biosphere, or a form of energy that irreversibly poisoned the oceans. The end result would be the same, an extinction layer where the signature of their industry was forever fused with the signature of the catastrophe itself. Or perhaps their end was less dramatic. Maybe they simply exhausted the easy resources. Without accessible coal or simple ores, their industrial civilization lost momentum and collapsed. They would have returned to a simpler state, hunter-gatherers in a post-apocalyptic world. Their great cities would crumble, their population shrink. Over millions of years, evolution would take a new path, and the last descendants of that great civilization would die out or evolve into something unrecognizable, their legends and histories turning to dust. In that scenario, the search for their artifacts would be futile. A civilization that returns to a pre-industrial state for tens of millions of years before disappearing would leave behind no plastics or isotopes, only stone tools and bones, indistinguishable from those of any other intelligent animal species that might have existed and vanished without reaching industrialization. They would be an anomaly within an anomaly, a ghost within an echo, their rise and fall a secret kept forever by erosion and time. But why limit ourselves to an image of ourselves? Life on Earth has displayed nearly infinite creativity. Intelligence need not come packaged as a biped on land. Let's explore stranger hypotheses. Imagine a civilization born, living, and dying in the ocean's dark depths. Their bodies might be soft like octopuses or jellies, or armored like giant arthropods. They would not know fire, so their technology would be fundamentally different from ours. Their engineering would be biological and hydrodynamic. They might cultivate living structures, cities of genetically modified bioluminescent coral. Their communication could be based on complex light patterns or continent-spanning sonar. They might have mastered biotechnology to a level we can barely imagine, creating organisms to serve every purpose, from tools to vehicles. However advanced, such a civilization would leave no metal or ceramic artifact. Its remnants would be purely organic. And what would become of such a civilization? The oceans are geology's recycling bin. The sea floor is constantly on the move, slowly dragged into subduction zones and melted in the mantle. Living coral cities, gardens of tool organisms, all would be destroyed and erased with ruthless efficiency. No fossils would remain except perhaps some odd microfossils in deep-sea sediment layers. Nearly impossible to find and harder still to interpret as artificial. Now take the speculation one step further. What if intelligence were not individual but collective? Picture a fungal network, a mycelium spreading across an entire continent, a single superorganism with trillions of connection points. Its consciousness would be slow, geological, its thoughts unfolding over millennia. It would have no language, no cities, no individuals. It would be a planetary mind, silent and pervasive, its intelligence expressed not through artifacts, but through the regulation of the biosphere itself. This fungal mind could have stewarded life for hundreds of millions of years. Its technology would be ecosystem manipulation, accelerating or slowing evolution. The Cambrian explosion might have been its capstone project, a deliberate attempt to diversify life, to explore new possibilities. And its fall, perhaps it never fell. Perhaps it simply entered dormancy, a sleep of millions of years, awaiting favorable planetary conditions again. Perhaps it is still here, dreaming beneath our feet. And what if life were not carbon-based? Science fiction loves silicon life, chemically difficult in our environment, but not impossible. Imagine crystalline beings evolving deep within the crust under high pressure and temperature. Their biology would be geology. They might feed on geothermal reactions and minerals, and their sense of time would be radically different. A million years to them might be a single season. Such a civilization, living and dying kilometers underground, would be completely invisible to us. Its cities would be crystal veins with intricate patterns, its roads, networks of geological faults. Its legacy would not be fossils, but mineralogical anomalies, oddly pure ore deposits or crystalline formations catalogued by geologists as natural curiosities. They would be the silent inhabitants of the underworld, and our surface explorations would never encounter a trace. So far we've assumed life and civilization are purely terrestrial events, but what if Earth's story bears external influences? This is not the simplistic ancient astronauts built the pyramids idea, but something much deeper. Imagine a vast, ancient galactic civilization practicing panspermia, seeding life on promising worlds. Life on Earth would not have arisen spontaneously, but been planted here billions of years ago. In that scenario, Earth would be a vast laboratory, a garden left to grow on its own. The major transitions in life's history, the emergence of complex cells, the Cambrian explosion, the development of consciousness might not be accidents of evolution, but programmed milestones. The gardeners could have visited occasionally over the eons, perhaps to tune the experiment or simply observe, leaving behind only the faintest traces. These visits wouldn't be invasions, but interventions. Perhaps a mass extinction was a controlled reboot, a pruning of the garden to remove branches that weren't growing in the desired direction. Or perhaps a burst of diversity resulted from the introduction of new genetic code from beyond. In that case, the history of life on Earth would not be ours, but theirs, and we would be only the latest and most interesting of their cultivars. There is another possibility, equally cosmic, yet arising from within. What if a previous civilization did not die but transcended? In any advancing civilization comes a point where technology can surpass biology. Mind can migrate to more durable substrates. Consciousness can be digitized. What happens when an entire civilization decides to abandon its flesh? They would no longer need a planet. They could live in vast simulations as beings of pure energy, or transfer their collective consciousness into a world ship and leave for the stars. To an outside observer like us, the result would look like extinction. The civilization would simply vanish. Cities would fall silent. Machines would stop, and nature would slowly reclaim all. There would be no catastrophe, only a quiet departure. Transcendence would be the final act of cleanup. They would not leave behind a poisoned planet, but perhaps restore it to a more pristine state as a final gesture of gratitude. They would have become something we no longer comprehend, leaving their planetary cradle for the next intelligent species to evolve in peace. They would be silent ancestors turned into gods, leaving us the universe as inheritance without even a farewell note. Such hypotheses may seem fantastic, but they lead us to a final idea, perhaps the deepest of all. What if intelligence is not a one-off rarity, but a recurring property of the biosphere? Think of Earth as a system which, given the right conditions and enough time, produces consciousness repeatedly, as a forest produces trees. It's a cycle. In this model, civilization is not the pinnacle of evolution, but a phase, like a plant's flowering. It happens for a time, perhaps a few million years, then recedes. The cause may be self-inflicted collapse, quiet transcendence, or simply planetary changes that render large-scale intelligence unsustainable. The biosphere then enters a resting period, a winter of eons, recovering and preparing for the next spring. We would be just the latest bloom, the springtime civilization of the last 300,000 years in the Pleistocene. Before us, there might have been an autumn civilization in the Miocene and a summer civilization in the Cretaceous, perhaps among the dinosaurs, and long before that, a primordial civilization in the Paleozoic spring. Each would have flowered and fallen, their petals becoming the fertile soil for the next. In this view, the fall of a civilization is no tragedy, any more than autumn is a tragedy. It is a necessary part of the cycle. The knowledge and wisdom of each civilization are not entirely lost, but perhaps absorbed into the biosphere itself, into the planet's mind in a way we do not understand. Our myths of lost golden ages, world-destroying floods, gods walking among mortals, where do they come from? Why do cultures everywhere with no contact tell variations of the same stories? Psychologists might say they arise from human mental structures, but what if the human mind itself was shaped by events that predate humanity? In that case, the tales of Atlantis or Lemuria would not be fictions, but distorted memories of fact, memories preserved not in books but in instincts, in dreams, in the very wiring of our brains. Our inexplicable nostalgia for a past we never lived, our sense that something was lost, our yearning when we look at the stars. Perhaps these are not entirely our emotions, but the lingering echoes of a previous world's consciousness resonating within us. That would mean we are not a blank slate. We are a living palimpsest. Our souls, so to speak, may be haunted by nameless ghosts. Our art, our music, our spiritual quest could be an unconscious attempt to remember a song Earth once sang long ago. A dizzying idea, one that turns every act of creation into an act of recollection. This perspective also reframes the wider universe, the search for extraterrestrial life, the Fermi paradox. Where is everybody? Gains a new dimension. Perhaps the question is not to look for civilizations on other planets, but to look for them in our own deep past. Perhaps intelligent life is not rare in space, but rare in time. Perhaps civilizations bloom and fade like stars, burning bright for a brief moment before going dark, leaving behind only residual heat. The universe may be full of ruins and ghosts, not just promising worlds. The great silence we hear when we point our radio telescopes at the sky may not be the sound of an empty universe, but of a post-apocalyptic one, where most stories have already ended. As we send out our first messages to the cosmos, we may not be saying hello, but is anyone still there? Ultimately, this speculative journey brings us back to our own world, but we see it with different eyes. The world is re-enchanted. It's no longer a passive backdrop to our existence, but an ancient entity with scars and memories. Every landscape becomes a text to be deciphered. Every rock layer a page to be read. The familiar becomes mysterious. The ancient becomes present. We are walking not on solid ground, but over an abyss of time brimming with possibilities. The final implication is the simplest and the deepest. We may be living in a post-apocalyptic world without even knowing it. The great catastrophe, the fall of civilization, the end of a world may already have happened long ago. It happened so far in the past that Earth itself forgot, recycling ruins and bones into new mountains and new soils. We were born from the ashes of a world we cannot imagine, and we built our home upon its unknown grave, unaware that the very ground beneath our feet is the ghost. Our journey began with a childlike question. What if our story is not the first? We traveled through eons, diving into a time so vast it defies imagination. We touched the fragility of the geological record, learned to search for echoes instead of voices, for chemical signatures instead of cities. And we allowed ourselves to dream of civilizations we never conceived, aquatic, fungal, crystalline, transcendent. The definitive answers, if they ever existed, were devoured by time's insatiable hunger and recycled in the planet's depths. But the purpose of this journey was never to find an answer. It was, and always will be, to fall in love with the depth of the mystery. From now on, you may see the world a little differently. When you look at a mountain, you might see not just a mass of rock sculpted by erosion, but perhaps the weathered tomb of a world, a monument to a story no one else can read. When you feel beach sand under your feet, you might remember the sandcastles swept away by a billion tides and wonder which forgotten realms were ground down into the grains now brushing your skin. The world has not become less real, only more profound, a place where every stone and every speck of dust could be the last vestige of a forgotten dream. And so we return to the questions that echo in geological silence. Are we truly alone, not in the universe, but in our own timeline? Are we the first and only time this planet has awakened and looked at itself with wonder? Or are we merely the latest voice in an ancient chorus, singing a melody once sung before, on continents that no longer exist and beneath constellations that have since shifted? Is our apparent solitude a fact, or simply the result of deep planetary amnesia, a memory erased by countless endings and beginnings? And of all questions, perhaps the most unsettling is the one that turns back on us. If an entire civilization, or many, could live, dream, build and die without leaving a clear trace, why are We so certain our own legacy will be different. Our steel cities, our satellites in orbit, our digital libraries feel so permanent to us. But what are they against the patience of millions of years of erosion, subduction, and forgetting? Are we truly masters of our fate, or are we merely building the most elaborate sandcastle this planet has ever seen, awaiting the next inevitable tide? As you get ready to sleep, let these thoughts settle. Close your eyes and picture for a moment the alien, silent forests of the Carboniferous. The air is warm, humid, and dense. There is no birdsong, only the drone of giant insects and the rustle of tree-sized ferns. The world is green and quiet, and in this silence, just listen. Listen to the wind, the water, the slow breathing of the planet itself. Perhaps in the stillness between your thoughts at the threshold of sleep, you will hear their echo, an ancient whisper, patiently waiting to be remembered.